You might get asked in your exam to draw how VQ ratio changes with height in the lung in an upright patient. So here's how to draw that graph. This is one of the few graphs that we draw that's backwards with the y-axis on the right-hand side. Start with VQ ratio on the y-axis with 1, 2 and 3, and on the x-axis we have height, so we start at 5th rib coming up to 1st rib. And the most important point to put on your graph is at 1, or VQ ratio of 1 at rib 3. That's your crossover point, which will make drawing your graph easier if you already have that in place. So this is blood, which is preferentially distributed to lower areas of the lung in an upright patient, and as you go higher up the lung, blood flow drops off quite dramatically. Remember, this is in an upright patient. This graph will look totally different in a supine patient. In an upright patient, you get a dramatic drop in blood flow. Now you get a similar drop in ventilation because the dependent areas of the lung are generally more compliant, so they receive better ventilation. But the drop is much less steep. So it's still dropping as you go up the lung, but obviously the gradient of this line is much less steep, and they cross at our crossover point at about rib 3. So that is where our VQ ratio by definition is 1, because you've got exactly the same blood flow to ventilation, so that's a 1-to-1 ratio. As you can see here, blood flow is greater than ventilation, so ventilation as a ratio is less than 1, it's less than the blood flow, so our gradient, our VQ graph starts down here. And by the time we get to the top here, it's flipped round. And actually our ventilation is about 3 times as much as our perfusion. So our graph ends up about here. And then what you end up with is a smooth graph that passes through that center point. And the key points on this graph are you've got a crossover at about rib 3, and you show that blood flow and ventilation both decrease as you go up the lung, but ventilation decreases more slowly, and therefore you get a changing over of VQ ratio. So VQ ratio is much lower at the bottom of the lung, and you have preferential perfusion and less ventilation. And then as you go up the lung, you get better ventilation and reduced perfusion, and the VQ ratio totally switches around.